All right, guys, I'm going to go over Unit 1A quiz, Form C. So just make sure it's Form C that you're looking at. Okay, at any point, feel free to go ahead and just pause, rewind, replay any parts of this video, or even skip ahead to just the questions that you missed. I'm going to record these page by page. Okay, we're going to simplify the following expressions. Off to the side, I probably would just go ahead and reference my perfect squares. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. You get the point, and just kind of look at these off to the side and think about them. So in this situation right here, I kind of am just picturing like $1.50, and that makes me think of taking out quarters. And quarters, right, those are going to be perfect squares. So 25, how many times does 25 cents go into $1.50? That'll be 6 times. Okay, now I can go ahead and take the square root of 5. When you take the square root of something, you multiply it to what's already out front. So 6 times 5 is 30, and then you have a rad 6 left underneath. Okay, just double check, can I divide the radicand by any other perfect square? I don't think so, so I'm done here. Okay, moving over to this one, it looks like we have a number and we have variables to deal with. Okay, 72, I could divide out 9 as an option. 9 times 8. There's other options as well, but let's go ahead and just take this route as an example. We have an odd exponent. So with an odd exponent, that's not a perfect square. It's a perfect square if it's an even exponent. So we're going to force it to be an even exponent by moving one of the variables off to the side, leaving 4 over here. I don't need to break up my y's, because that's raised to an even exponent, which is perfect. And then keep in mind, z is raised to the exponent of 1. So I'm just going to go ahead and use my highlighter to indicate which ones are perfect. Okay, these are the pieces that I'm going to go ahead and remove from the radical. So the square root of 9 is 3. That's done. The square root of x to the 4th is x to the 2nd. Remember, you just divide the exponent by 2 when you take it out of the radical. And then y to the 3rd, so those are gone. Now what do I have left underneath? An 8, an x, and a z. The issue is that 8 is actually divisible by 4, one of our perfect squares. So that means I need to continue breaking this down. So this will be 3x squared y cubed rad 4 times 2 times x times z. Looks like I could take out the square root of 4. When you take out the square root, you're going to multiply it to the front. So 3 times 2 is 6. And it looks like that is all we have left to simplify. Moving on to number 3. What's really nice about this one is this is a perfect square. Oops, I didn't finish my list, but it's the next one. 9 times 9 is 81. 10 times 10 is 100. So the square root of 81 is 9. Once you take the square root of something, it's no longer underneath the radical. Remember the conversation we just had a second ago, right? When you take the square root of a raised to the 10th power, it's going to be a raised to the 5th power. You divide the exponent by 2. Okay, that's because a to the 5th times a to the 5th equals a to the 10th. Just like 9 times 9 equals 81. Okay, and if you think about why this makes sense, right? You have a times a times a times a times a, right? You're multiplying a to itself 5 times. But then you're also multiplying that to a times a times a times a times a, right? And that's a total of 10 a's that you have when you multiply that out. Okay, so this is our final answer. Once you take the square root of something, it's no longer under the radical. Moving over to addition. With addition, you can only add radicals if they are like terms, meaning they have the same number underneath the radical. If they do have the same number underneath the radical, then you can combine the coefficients. 5 plus 3. That's going to give us 8 rad 6 as our final answer. Moving down here, we have addition and subtraction. They have to be like terms in order to combine them. Well, maybe this will be a like term once I simplify it. Okay, I can divide one of my perfect squares out of 12, and that's 4. Okay, so negative 6 rad 4 times 3. Okay, the other terms I cannot break up any further, so I'm just going to copy them down to keep track of my work. So the square root of 4 is 2. You're going to multiply that to the outside. Negative 6 times 2 is negative 12. And just a rad 3 is left underneath. Now let's see. Like term, like term. So let's combine the coefficients. Negative 12 plus 8. Let me slide my paper up. It's going to give me negative 4 rad 3 minus 4 rad 2 as my final answer. Okay, and last but not least, we have multiplication. Okay, for multiplication, you do outside times outside and inside times inside. So 5 times negative 2 is negative 10. Inside times inside is 60. But here's the issue. A lot of you guys left your answer unsimplified. You can most definitely take out a perfect square from 60, right? Maybe 60 divided by, we'll start with 4, okay? And go up from there if we can. The square root of 4 is 2. When you take the square root, you're going to multiply it to the outside. So negative 10 times 2 is negative 20. And you have a 15 left underneath the radical. 15 is not divisible by any of our perfect squares, so we're done simplifying.